Hi, welcome to this tutorial on the normal approximation to the Poisson distribution. And to demonstrate this, what I've got is an example here where we have, in a particular factory, the number of accidents occurring in a month follows a Poisson distribution with a mean of 2. Find the probability that there will be at least 22 accidents in a year. Now, first of all, if I was doing a question like this, what I'd want to do is define a random variable. And I'm going to say that x be that random variable, which represents the number of accidents occurring in a year, where x is distributed as a Poisson distribution with a mean of 24. I get the number 24 because if there's a mean rate of 2 accidents per month, then over a year of 12 months, there's going to be 2 times 12, which is going to be 24 accidents. Then what I would normally want to do is work out then what the probability of x, that's the number of accidents, being more than or equal to 22, at least 22. Now, that would mean working out the probability that x equals 22 plus 23, 24, and so on. It would be endless. So knowing that all the probabilities add up to 1, it's easier if I just do 1 minus the probability that x is less than or equal to 21. And that's going to mean that I'm going to need to work out 1 minus the probability that x equals 0, plus probability x equals 1, and so on, all the way up to 21. And that's a lot of calculations. Remember that if I'm going to work out any of these probabilities using the formula that if x follows a Poisson distribution with a mean of lambda, each of these probabilities is worked out through this formula here. So if I was to do that calculation, I'd have a sum something like this. And that is quite lengthy to work out, but I did it on a calculator and this is the answer, 0.68607 and so on. Now, this obviously is very impractical to do, and luck has it that we can approximate some Poisson distributions to the normal distribution. And I'll show you why, and I'll show you also what those conditions are. Now here you'll see that I've got a Poisson distribution sketched out for a mean of 2. You can see mu, the mean is 2, and the variance is always the same as the mean for a Poisson distribution. Sigma squared, that will be equal to 2 as well. And you can see the shape of it, okay? Now, if I increase the mean, let's say we make the mean 3, the distribution moves over to the right. And then if I increase it to 4, and then 5, 6, 7, 8, 9, 10, you can start to see that the shape is changing as going towards a bell shape. So let's carry on increasing the mean from 10 here. 11, 12, 13, 14, 15. The shape is now tending towards a normal distribution. If we increase the mean from 15, 16, 17, 18, 19, 20, then at this point here, we generally say that if the mean is greater than 20, we start to have the distribution approximating to a normal distribution. So that's with a mean of 20, 21, 22, 23, 24, 25, and so on. You can see the shape of the curve is not really changing, but it is still retaining that normal distribution. So what we're saying then is that if x follows a Poisson distribution with mean lambda and lambda is greater than 20, then x is distributed as a normal distribution approximately. And the two parameters for a normal distribution are the mean and the variance. The mean is lambda, but for a Poisson distribution the variance is also lambda. So we can use this to our advantage to save us doing a calculation like this, because in this example the mean is 24 and clearly it is greater than 20. So what we'll do is we'll try this now by this new method. Now if I look at the probability distribution for this Poisson model with a mean of 24, it will look something like this. And because the mean is greater than 20, you can see it's taking up this normal distribution shape. If we put a curve around it, then you can see quite clearly that we've got that normal distribution shape. So we can say that since the mean lambda is equal to 24 and that is greater than 20, then our random variable x is distributed as a normal distribution with a mean of lambda 24 and a variance of 24 as well, but it approaches that distribution approximately. Now we are asked to find the probability that there will be at least 22 accidents in a year. In other words, we've got to work out the probability that x is greater than or equal to 22. Now 22 on this scale will be here. There's 20, 21, 22. So we just mark that in as 22. And normally then we would just need to work out the area to the right of the 22, and that area would give us the probability of being greater than 22. But we have to make what is called a continuity correction, because we've got spaces between these black lines which need to be filled. We fill them with rectangles of unit width, and because we filled it with rectangles, you'll notice that part of the rectangles stick outside the curve and other parts of it are inside the curve, and so you get a little bit of empty space here and you get a part of the rectangle area sticking outside the curve. So to compensate for this, we need to apply what is called a continuity correction, and I'm assuming that you're familiar with continuity corrections. If not, you can always check out how they work by just clicking on the link that you should see in this video. But what we do anyway is we just consider the rectangle round the 22, this rectangle that you should see flashing. Now we need to think about this rectangle, and I'll remove the other rectangles so we've got a cleaner drawing. Now in this example, because I want the probability of being greater than or equal to 22, I consider the area to the right of 22, but because I've got to include 22, that area carries on up to the left-hand side of this rectangle. And this value here would be 21.5 because the width of the rectangles is 1 unit. If it had been just greater than 22, then I would have considered all the area up to the right hand side of the rectangle, as I've mentioned in my video on continuity corrections, and that value there would have been 22.5. So if we just shade that area in, then with the continuity correction, working out the probability that x is greater than or equal to 22 is approximated to the probability that x is greater than 21.5. Now that I've got this, I'm working off the normal distribution here. And in the usual way, we would want to work out what the standardized z value was. And that would be equal to the probability that z was greater than the observed value, which is 21.5, minus the mean, which is 24, and that is all divided by the standard deviation. Well, the variance was 24, so the standard deviation would be the square root of 24. And if you work this out, you find that you get the probability that Z is greater than a negative number, which you'd expect because it's to the left of the mean. And it is greater than minus 0.5103, and so on. Now, if you're working out the probability of Z being greater than a negative number, normally you'll have to reverse this round to have access to the table. So this is exactly the same as the probability that Z is less than 0.5103, and so on. I'm assuming that you're familiar with these basic results now for the normal distribution. And then if you look this value up in the tables I looked up just could only handle 2 decimal places, so I had to look up 0.51, and what I got was 0.6950. Depending on your tables, you might be able to get this slightly more accurate. How does this compare with the actual answer that we worked out earlier? Well, if we look at the actual answer, it was 0.68607, and so on. Not bad really, because to 1 decimal place or 1 significant figure, this would be 0.7, and this one too would be 0.7. So there's not much in it, and yet this is so much easier to work out. So I hope that's given you some idea how we would go about questions like this. So providing the mean is greater than 20, then you can apply a normal approximation. Don't forget your continuity correction. This will always change depending on whether you're working out greater than or equal to a value, greater than, less than or equal to, or less than. And as I said earlier, you can always check out continuity corrections, how we make them, just by clicking on the link that you should see on continuity corrections. Okay.